Derivatives of sine and cosine functions. Okay, so in this one, what we're going to be doing is we're going to be taking the derivatives of things like sine x and cos x, right? And different variations of that. So as a base, though, we need to figure out what the derivative of sine x is. So to do that, we're going to go back to first principles. Okay, so we're going to take the derivative of sine x using limits to begin with. But the good news is once we figure out what the derivative of sine x is, then we can kind of just use that, just like what we've been doing with derivatives in the other units, right? We've been doing the shorthand form of it after we found some patterns. All right, so first one here. So for sine x, we're going to be setting it up like this. So f prime of x is equal to the limit as h approaches 0, rather, of sine x plus h minus sine x over h. Okay, so remember how that works, right? Because it's f of x plus h. So now that our function is sine, right? So that's why it looks like that. So now the next step we're going to do here, well, this is actually an addition of angles identity there. We can split this up, right? So I'm going to write this again, but I'm going to rewrite this part of it. So this would be the limit as h approaches 0 of, and then this would turn into sine x cos h plus sine h cos x minus sine x. And then that's all over h. Now, I'm going to write that again, but I'm just going to move some things around so we can look for some patterns here. So the limit as h approaches 0 of, and I'm going to just actually swap these two terms just so that they're kind of sitting in the right order, the order I want them in. So that's sine x cos h, and then minus sine x, and then plus sine h cos x. And then that's all over h. Now, I'm going to just factor this part of it. I'm going to like pull a sine out of just those two terms. Okay, so this is the limit as h approaches 0 of, and like I said, factor a sine out. So now we have sine x, and then we're left with cos h minus 1 plus sine h cos x. Okay, and now that was all over h, right? But to save a little room here, that would be the same thing as having this term over h and this term over h. Okay, so just kind of splitting those guys up. Now, why did we do that? Well, it's really because of this part right here. Can you see it? What's that equal to? Right, from the last lesson there, cos x minus 1 over x, or in this case it's h, is equal to 0. Okay, so we can actually, from this point, just put it in. So in the next step here, I'm just going to write it out as sine x, which we don't know what it is, right? We don't know what x is, right? Because this is as h approaches 0, but it won't matter here in a second. So sine x times, and then this would be 0. So I'll say times 0. And then plus, and then this part right here, sine h over h, what's that equal to? Well, that's 1. And then we're just left with cos x. So that's neat. Look at 0 times sine x, those cancel. All we're left with is cos x. All right, so it looks like the derivative f prime of x there was equal to cos x. What an easy derivative, right? So now whenever we're told to find the derivative of sine x, just cos x. All right, so now let's look at cos x. So we'll do the same thing here. So say f prime of x is equal to the limit as h approaches 0 of cos x plus h minus cos x all over h. So this would be the limit as h approaches 0. Now, again, I'm going to use my addition of angles identity. So this would be cos x times cos h minus sine x sine h minus cos x. I'm going to do the same little trick there. I'm going to swap these two guys around just so I can manipulate a little bit different. So that would be the limit as h approaches 0 of cos x cos h minus cos x, and then this last part minus sine x sine h. Just like before, I'm going to, when I'm done writing this, I'm gonna factor out a cos this time, just out of this part. So this would be cos x, and then I have cos h minus 1. Okay, and you know what? Why don't we do this right now? Oh, I got lazy, guys. Sorry, that was supposed to be over h the whole time. Over h. Okay, and this is still over h now. So now instead of writing it all over h, I'm going to write just this part of it over h, just like what we did up here, right? And then minus, and then this part over h. Sine x sine h over h. Okay, perfect, because we know what this is, right? That's equal to 0. And we also know what this is. That's equal to 1. Now, you might be thinking, okay, well, if sine is equal to cos, or for the derivative, then the derivative of cos should be equal to sine. That's close, but yeah, this is going to change things up a little bit, isn't it? So this time when we throw it in, it'll be cos x times 0 minus sine x times 1. So it ends up being negative sine x. So we have to keep an eye open for that now. Whenever we take the derivative of cos, it's actually equal to negative sine x. So these derivatives are on your formula sheet, but you may be asked to do this, pretty much exactly what I just did there, on your exam. So you are responsible for being able to do the same thing I just did there. Okay. So yeah, these are on your formula sheet too. I won't go on your formula sheet, but make sure you find them and know where they're at. Okay, so that's kind of the main idea between finding the derivatives of sine and cos. So now when we get deriving these things, we just have to make sure that we're paying attention to the chain rule, because this is kind of like the inside of my chain, right? Like when we were doing the chain rule before, it might be like 3x plus 2 squared, right? Remember how we had to derive the outside and then multiply by the derivative of the inside? Well, we'll just have the same thing going on when we do this as well. So we'll start with sine first. That's the outside. So we'll say y prime here. So the derivative would be, well, the derivative of sine is cos. So it would be cos, and now I'm just going to write the inside again as it is. Okay, so that was the derivative of the outside. And then we just need to make sure we chain rule it. So then that would be times 2x. Right, just the derivative of the inside there. Okay, and then just maybe write a little bit different. 2x times cos x squared plus 5. Easy, right? That's not too bad. Okay, so let's do this one. So f prime of x is equal to, okay, well, the 5, the coefficient out front, right, that doesn't even really play a part. You can just pull that out. Don't even worry about it. So the 5 will just hang out. So that's 5 times, and now the derivative of cos was negative sine. So it's negative sine of negative 3x. And then we have to take the derivative of the inside. So then that would be times negative 3. So cleaning all of that up, I've got two negatives going on, so those cancel. So I've just got 15 times sine negative 3x. All right, so this one, sine, just be careful on this one, right? Because we'll have to make sure we chain rule this. So I would recommend rewriting this as sine x squared and then all in brackets to the power of 3. It's a lot easier to see how the chain rule would work on this. So we'll take the derivative of the whole thing to begin with, right? Just like what we always did when we had, like, you know, something like an expression to the power of 3. So the first part, so for y prime, the very first part would be bring the 3 down front. So that would be 3. And then write it all again, right? Sine and all. Like, I'm not changing anything for this first step. So this would be sine x squared. And now to the power of 3 minus 1. So that's going to be 2. So there you go. That was the first part of the chain. Now I'm focusing in on the next part. So now instead of sine, I need to take the derivative of sine. So that's going to be cos. So that would be cos and then x squared. Okay, perfect. That's that part. And then we're working our way into the last one. So now the last part is the derivative of x squared. So that would just be times 2x. And there you go. There's our derivative. I guess we should clean it up a little, though. That would just be 6x times sine squared x. Just writing this a little different. And then cos x squared. And if you want to make sure that you don't get this mixed up, because cos x squared looks a lot like sine squared x, right? Like, this is different. You might want to put little braces on there just to show that it's cos x squared, like you're taking cos of x squared. All right, next one. So now we have a situation where we got, you know, x to the 4 times cos x. So this is a job for the product rule. So this would be f prime of x is equal to, so if this is my f and this is my g, then this would be x to the 4 times the derivative of cos, so negative sine x, plus, I'm going to put that in brackets, plus, and then the derivative of f, so 4x to the 3 times cos, times g, so cos x. So that is the derivative, so now we'll just kind of clean it up a bit. So that would be negative x to the 4 sine x plus 4x to the 3 cos x. Okay, and that really would be it, but maybe, you know, these both have an x to the 3 in them, so let's factor out an x to the 3. So then we'd be left with x sine x plus 4 cos x. Okay, next one. So now we've got some x's and some y's randomly. So this looks like a job for implicit differentiation. So let's get started. So let's take the derivative of this part first. So this would be, so the derivative of cos is negative sine, and then I have to write the inside again, so x, y. And then the derivative of the inside, right? Now I've got to do the product rule with those. So that's going to be, like, that's my f and that's my g, right? So this would be x times y prime plus, And then the derivative of x is 1 times y. So just to make sure you see where that y prime came from, go back on that. So if I've got x and y, right, that's my f and that's my g. So this would just be f. And then this part here would be g prime. Okay, so because the derivative of y is 1, but then we have to multiply it by y prime, right? The chain rule there with implicit differentiation. And then the next part would be f, or sorry, f prime, and then g. And this is all with respect to x, right? So in this case, I didn't have to multiply, I didn't have to chain rule that by multiplying by, you know, x prime or something, right? It's because this is with respect to x, so that just gets to stay as just a 1. I don't have to worry about my x's. It's just my y's that would have to be chain ruled with the derivative, okay? So, all right, so that part, and then that's equal to, and then this would be just the derivative of this would be 3y squared, but then times y prime. Okay. So now I'm kind of locked in right now. So and what I mean by this, because I'm multiplying, you know, this by this, I can't really do that much with it. I'd like it if I could free those terms up by just expanding this in. And that won't be too bad, right? There's not that much going on. So let's multiply that in. So that would be negative x y prime sine xy. Okay, so that's just that first arrow going in, doing that part. And then minus y sine xy, yeah. And then that's equal to 3y squared times y prime. All right, so now remember what we're after here, right? We want to find the derivative. So I want to solve for y prime. So our strategy here is typically to get the y primes on the same side and then factor out the y prime. So I'm going to move this term to the other side. So we'd have negative y sine xy, right, just that, is equal to, and then I'm just writing this one again, 3y squared times y prime. And then bringing this over, so now this would be plus xy prime sine of xy. All right, so now, like I said, I need to free up, I need to turn these two y primes into one y prime. So let's factor it out. So we've got negative y sine of xy is equal to y prime. And then you'd be left with 3y squared plus x sine of xy. All right, last step, just to get rid of all of this, right? And we'll do that by dividing both sides. So this will be negative y sine xy all over this chunk. 3y squared plus x sine, come on, pen, xy. Okay, so number 2, determine the equation of the tangent to the curve y is equal to sine x over cos 2x at the point pi over 6, comma 1. And then write your final answer in general form. Okay, so we've done ones like this before, right? But now we're dealing with a trig function instead. So if I want to write it out as a line, then really you always need two things. You need a point. I'm going to need like an x value and a y value. But then I'm also going to need the slope. Okay, well I need the derivative, right? So I need the slope. So therefore, I need to find the derivative. Okay. All right, so let's start. So we'll say dy dx. We haven't used that in a while. Let's write it out. Let's write it out that way. Okay, so now if I'm taking the derivative of this, right? So this would be my f and this would be my g. I'm going to use the quotient rule for this one. Okay, so this would be, well, let's remind ourselves here. This was, quotient rule was g times f prime minus f times g prime all over g squared. Okay. So applying this to our situation, this would be cos 2x, right? That's just g, times cos x, the derivative of sine, plus sine x, right? Just f, and then the derivative of g. Oops, sorry, and I wrote plus when should I wrote minus. So anyway, so sine x, and then times the derivative of g would be negative sine 2x times 2. Just derivative of the inside, right? And then that's all over cos 2x and then squared. Okay, so let's simplify this up a little bit. So this would be cos 2x, this one doesn't really change, cos 2x, cos x. And now this would become plus, right? Because I got that minus in there and that one, so now plus. I'm going to write this as 2 sine 2x and then sine x all over cos 2x, and then that's all squared. Okay, so now we're set up pretty well because we actually want to get a number out of this, right? So in this case, remember what x was. X is pi over 6 because we want to figure out what the slope of the line is at that value of x, right, at that point. Okay, so let's use that. So we're going to be throwing that in for all of our x's. So this would become cos 2 times pi over 6, and then cos, do that, and then cos pi over 6 plus 2 times sine 2 pi over 6, and then sine pi over 6. And then that is all over cos of 2 pi over 6. And then that's all squared. All right, so now the good thing is we know what those are, right? This is really the unit circle is what we should be thinking here. Because cos of 2 times pi over 6, well, that would be the same thing, just canceling that, right? That'd be pi over 3. So what is cos pi over 3? Well, that would be a half. Okay? And then on to the next one. So cos pi over 6, that would be root 3 over 2. That's the x value when cos is, or when the angle is pi over 6. All right, moving on. So then plus 2. Now the same thing, right? Sine of 2 times pi over 6. Well, that's really, the 2 and the 6 simplify. That's pi over 3. So what's sine of pi over 3? That's root 3 over 2. And then the last part here is sine pi over 6. That would be a half. All over. Now, looking down here again, cos 2 times pi over 6, that's really pi over 3. Okay, so that's going to be a half, but then we're squaring that. All right, we can do that. Let's simplify this first part up a bit. That would be root 3 over 4 plus 2 root 3 over 4. And then that's all over. And then squaring the bottom there would be 1 over 4. Okay. Now, you can simplify the top there, right? Put it all over a common denominator. So that'd be root 3 plus 2 root 3 over 4 all over 1 over 4. Now you can probably see right now that we can just cancel those, but if you like, we can flip that around. That'd be, I'm going to need lots of room for the next part anyway. So that's going to be root 3 plus 2 root 3. Well, actually, why don't we just combine those right now? Let's call that 3 root 3 and then over 4 times, and then flip this, right? When we're dividing by a fraction, we'll multiply by the reciprocal, so that'd be 4 over 1. So our 4's cancel. So this is just 3 root 3. Okay, and what was that? That was our slope. Okay, that was our derivative. That was our slope of our line, right? So now we kind of have everything we need. We have an x value and a y value and a slope. So back to grade 10 math, right? We've done these. So let's start off with our point form. So point slope form. So y minus y1 is equal to m x minus x1. And then we'll just kind of throw in everything we know. So this would be y minus 1. Okay, if you don't know where that's from, that's just our y value here, right? So 1. Our slope, we now know, is 3 root 3. And then x, and then our x value there was pi over 6. So minus pi over 6. Okay, I'm going to write this part again. Y minus 1 is equal to. Now I'm going to expand this one out. So this would be 3 root 3 times x minus 3 root 3 times pi over 6. Now I'm going to write it all again. Y minus 1 is equal to 3 root 3 times x, and then just cancel the 3 and the x, right, leaving a 2. So that'd be minus root 3 times pi over 2. Now if I want this in general form, then I don't want fractions. Okay, so I got to get rid of that 2 in the denominator. So I'm just going to multiply everything by 2. So multiply this by 2, this by 2, this by 2, and this by 2. So now we've got 2y minus 2 is equal to 6 root 3x, and then those cancel. So minus root 3 times pi. Now we're pretty much there. So we just want to leave like a positive x value. So I'm just going to get it's already positive over here, so I'll just leave it on the right side. Bring these two over to the right side. So we've got 0 is equal to 6 root 3 x, and then minus 2y. And then the last part you might not know what to do with here. You just have to leave it the way it is. It would just be, so it would be positive 2 and then minus root 3 times pi. This is like my c value. The two of those together would be your c. Right? That's just the most accurate way to leave it. All right, so I'm actually going to leave this next question. It's just not like any of your homework questions, and I just checked it's not on your quiz or your exam. So for the sake of time, I think let's focus on what we've done there.